Alright, we're going to talk about powers of polynomials and the product, which means multiply, of binomial conjugates. Yikes, those are some scary sounding words. Remember, just break it down. Product means multiply, binomial means two terms, conjugate I'm going to tell you about here in just a little bit. Alright, so here's rule number 2. This rule says that when you have two different bases that you're multiplying and you raise those to a power, then you raise each base to that power. So if I were to have 2x raised to the third power, that means I've got 2 to the third power, and I've also got x to the third power. Now, I do know that everybody should have a calculator, and so you should be able to do 2 to the third power. That means 2 times 2 times 2, which is not 6, it is 8. 8x to the third power is what that would be. Alright, let's move on. Okay, so let's look at example number 1. So I've got x times y, and I've got that whole thing raised to the seventh power. So I've got x to the 7th power, and I've got y to the 7th power. And you can't do anything else to that, so that is your answer. Okay, so let's take a look at number 2. So we've got 7 times p, and that quantity is squared. So that means we're going to have 7 squared, and we're going to have p squared. Now, anywhere where you have a number that could be raised to a power, and you can do that math, go ahead and do that math. So 7 squared is 49. We don't know what p is, so we're just going to leave it p squared. Alright, let's take a look at this last one. So you have to be really careful whenever you have a negative number inside of a set of parentheses. So this means negative 2 to the 4th power. Then we've also got x to the 4th power, and we've got y to the 4th power. And whenever you multiply negative 2 times negative 2 times negative 2 times negative 2, you get really 4 times 4, which is 16, positive 16, because you have an even number of negative signs, x to the 4th, y to the 4th. And that's it. You're done with that. Okay, these right here are just some formulas for memorization. Again, I'm not a person who really thinks that memorizing is really required in math. I think if you understand what's going on, you never really have to memorize a formula. So in this case, you can write this down, you can memorize it if you want, but I'm really going to show you a way that you can do this without ever having to memorize this formula. Alright, so here's what I'm talking about. This means 5x minus 4, whenever you have that squared, that means 5x minus 4 times 5x minus 4. So if you will write this out every single time, you will never forget what you're doing or have to memorize that formula. Now just distribute. And please don't just square that and call it good. You're going to miss this every single time if you do that. So write it out, draw your arrows, combine your like terms, take the time to do this right. So 5x times 5x is 25x squared. 5x times negative 4 is negative 20x. Negative 4 times 5x is negative 20x. And negative 4 times negative 4 is positive 16. Now we do have like terms here and here. So you've got 25x squared minus 40x plus 16. And that's it. You're done. So now let's look at the next one. Again, write it out. Take the time to do that. 3x plus 5y times 3x plus 5y. So we're going to multiply 3x times 3x and 3x times 5y. So I've got 9x squared plus 15xy. I'm going to multiply 5y times 3x, and I have positive 15xy. You could put yx, that's the same thing as xy. And you've got 5y times 5y, which is 25y squared. Our like terms are here and here. So I've got 9x squared plus 30xy plus 25y squared. And that's it. We're done with this problem. Okay, so whenever you have two terms inside a set of a parentheses, two different sets of parentheses, but they're the same numbers, and the only difference is one has a plus and one has a minus, then this is what we call a conjugate pair. Whenever you multiply a conjugate pair together, something crazy always happens. It happens every single time, but that middle term, it drops out. It goes away. It creates 0. And I'm going to show you what I mean. Alright, so check this out. I've got x times x, which gives me x squared. I've got x times negative 5, which gives me a negative 5x. I've got a positive 5 times x, which gives me a positive 5x. And I've got a positive 5 times a negative 5, which gives me a negative 25. Whenever I combine my like terms, I get that those guys cancel each other out. And I'm left with this right here. So again, this is also a conjugate pair. Only differences are pluses or minuses. So I've got 3x times 3x, which is 9x squared. I've got 3x times 8, which is a positive 24x. I've got negative 8 times 3x, which is a negative 24x. I've got a negative 8 times a positive 8, which is a negative 64. Here are my like terms, and notice one's positive, one's negative, so that means they cancel each other out to create 0. And I'm left with just this. Alright, let's look at this last one. Again, we have a conjugate pair. 2a times 2a is 4a squared. 2a times 7b is a positive 14ab. Now I've got a negative 7b times 2a, which is a negative 14. You could put ba, but typically we write them in alphabetical order, so I'm going to put ab. Negative 7b times a positive 7b is a negative 49b squared. So there's my like terms, but notice one's a plus and one's a minus, so they create 0, and that goes away. 4a squared minus 49b squared, and there we go. That's it. Alright, that's it for today, so send me a message if you need any help.